X.4, simplify rational expressions. What a rational expression is a ratio is a fraction. So everything that we're going to see today is going to be fractions, basically with numbers and letters in them, and we are going to simplify them. If you do not have a good understanding of factoring, which was Unit J, that's when we spent so much time on Unit J, you might have a struggle with this, but I will try to get you through it. Okay, so on the first one, there basically is two ways of looking at this. I'm going to do it the easier way first, but you're not always going to be able to do it this way. And then I'll show you the factoring way, and factoring is always the safest way of doing it. So on this, we have three terms. We have 30j, we have 10j squared, and we have 7j. Now, because I've highlighted them all individually, can you tell me something about all three of them? Compare them. Is there something in common with them? And the answer would be yes. They all have j's in them. So what's the most amount of j's that all of them have together? Do all of them have at least one j? Yes. Do all of them have at least two j's? No. So whenever we're simplifying, we are reducing. And so we're going to take a j out of everything. So I'm going to take a j out of the 30. I'm going to take a j out of the 10j squared, which leaves me with a j. And then I'm going to take a j out of the 7. And that would be the fastest way of doing this problem. Now, not all of them are going to be able to be done like that. So let me show you another way. So we'll leave the top alone because there's nothing that we can do at the top. But on the bottom, remember on Unit J, the first thing I ask you to ask yourself is there anything that we can take out? And yes, we can take out a j. And if I take out a j, then I'm left with this. And so then I look at what's on top and what's on the outside of the bottom, and the j's will cancel each other out. So we're left with 30. That's a 30. 10j plus 7. So I got the same answer both ways. Now I'm going to try to do that on all of these that I can show you. If there's more than one way of doing it, I'm going to try to show you those ways. Alright, so on this one, there are three terms. Everything has an m in it. So I can take an m out. So that leaves me with 48. Leaves me with an m. And if I take the m away of just the m, I am left with a 1. So that is one way of doing it. Or we leave the top alone. We take an m out of the bottom. The m's cancel out. And we're left with 48 over m minus 1. Now on the next one, not all of them have h's in them, so we are not going to be able to just cancel everything out. The top expression is a trinomial with a leading coefficient of 1, so we're going to have to factor. H, bring the first sign down. A positive times a positive is a positive. What multiplies to get 46 and adds to get 25, 23, and 2. Bigger number there, smaller number there. So I factored 23 plus 2 is 25, 23 times 2 is 46. Then we're going to bring the bottom down. And looky there. These are so fun. I love doing these because those will cancel. And the simplified form is h plus 2. Okay. On this, there is two ways of doing this. I see a 10, a 16, and a 12. I see all of them are even. Because all of them are even, I know at least 2 goes into them. But I'm going to pause for just a second and see if anything else goes into 10, 12, and 16 besides 2. And the answer is no. So if I divide everything by 2, I get 5h plus 8 over 6h. Now, not everything has an h in it. Because of this plus sign, I can't cancel out the h's with the 5 and the 6. If there is no multiplication involved, then I can't just cancel out one term to one term. So this would be the answer. But if I look at 10h plus 16, okay, well, there's a 2 in it. And that would leave me with a 5h plus 8. And I can't do anything to the bottom because it's just one term. And see, now this 2 is being multiplied, so I can reduce the 2 and the 12. And that would leave me with a 1 on top, so that just leaves 5h plus 8 and 6h. So that's one way of doing both of them. Okay, there's not a number that goes into all 4 numbers. There's not an m in everything, so I just have to start by factoring. And on the top, I can factor out an m, and that leaves me with 5m minus 6. I cannot do anything to the bottom, so I'm going to write it down. The 5m minus 6's cancel out, and that leaves me with just m. Nothing goes into 421 and 5, so we're just going to factor. We're going to take a 4 out, leaves me with d plus 5. We're going to take a d out, leaves me with d plus 5. Those cancel out, and 4 over d is your answer. Aren't these fun? I love them. Okay, when it's just one term on top and one term on bottom, just kind of pause and look at it. If you have j to the 4 on top and j to the 4 on bottom, those automatically cancel out, which leaves you with 4 over 44. But 4 over 44 will also reduce by 4, which leaves you 1 over 11. Excuse me. H to the third over h to the third, because they're exactly the same, those cancel out. You have 4 j's on top and you have 3 j's on bottom. 3 of those j's are going to cancel out and leaves you with how many and where? It leaves you with just 1 on top. And 21 over 7 reduces to 3 on top, so that would be 3j. And now we have, can't do anything with v plus 3. But I can take a v out of the bottom, which still leaves me with a trinomial. So I'll have to factor that also. Bring the plus sign down. A positive times a positive is a positive. What multiplies to get 21 and adds to get 10? 7 and 3. Put the bigger number first, smaller number second. And looky there. Those cancel out. Because the top cancels out, we are left with a 1 on top. And then we are going to multiply that back out and get v squared plus 7v. Take a p out, leaves you with p plus 2. Trinomial on bottom, and we just did this one. No, we didn't. Never mind. What multiplies to get 10 and adds to get 7? 5 and 2. P plus 2 over p plus 2 cancel out. Leaves me with p over p plus 5. Okay, z minus 2. Nothing can happen to it. But on the bottom, we have a trinomial, but the leading coefficient's not 1. So remember, we have to multiply. Bring the first sign down, and a negative times a positive is a negative. So it multiplies to get 18 and adds to get 4. Good grief. Well, it multiplies to get 18 and adds to get 13. Well, I couldn't think of anything, so I figured out that I messed up because I told you to multiply the 2 and the 18, but I did not do that. So we get 36 by 2 and 18, and now we have 9 and 4. The 9 and 4 go there, but remember we have to put the 2 back in. On these, something is always going to cancel. So if you don't get anything that cancels, then you've probably done something incorrect. So just keep working with it or ask me about it. 39 goes into both of the tops, so I'm going to take a 39 out. And we're left with that. 3 goes into the bottom. So I'm left with that. And then 39 and 3 reduced to 13 over 1. We're going to distribute that 13 back in there. So 13 times W is 13W. 13 times 1 is 13. All over W minus 5. Alright, we're going to take a K out. And that leaves us 4K squared minus 9. This is a difference of squares. The K is left, or stays. So the square root of 4K squared is 2K. The square root of 9 is 3. One's a plus, one's a minus. Okay, you're not going to like me very much for the bottom. 12, 32, and 21, there is nothing that goes into all three of those, unfortunately. So we have to multiply this. And we have K squared plus 32K. And then when we multiply them, we get 252. Now, your factor chart does not go up to 252. So you're going to have to make a T-chart on everything that multiplies to get 252 and adds to get 32. I have already done it to take away the time. So 2, 126, 384, 463, 642, 736, 928, 12, 21, 14, 18. There's only one of these pairs that multiply to get 252 and add to get 32, which is 14 and 18. So those are the ones that we're going to have to use. So I'm going to do that right here to save some space. Then we have to put the 12 back in. So we have to reduce by 6, so 3 and 2, 7 and 6. So it's going to be 2K plus 3 over 6K plus 7. Those cancel out. We have to distribute the K back in. So 2K squared minus 3K over 6K plus 7. Hopefully the rest of yours are not going to be as hard as that one. That's pretty much as hard as it gets. Good luck. Ask me if you need help.